Hi guys. So we're back this week with another lab. So you should have a lab in your Canvas module that says chromatography lab, and that's what we're going to be starting with today. So a chromatography lab is a confirmation test. So last week we did presumptive tests, which means that it probably is the drug because it's acting the way we think the drug would in those tests, but it is not confirmed. It's not for sure. More tests are needed. That's just a fast and easy test. A chromatography test is a confirmation test. So it actually should be confirming that yes, this is the drug, the toxin, the ink in question, as in today's lab will be ink. So what chromatography tells us is that how fast the mixture separates is something that can be important to note, is how fast they're separating. Some of them separate really slow, some of them separate really fast. They can also tell us how many, or something about the drug, of how many components the mixture is made of. There are several different types of even like medicines that are made of 3 components. So if it separates into those 3 components, then we know it's that drug in question. And then RF values. So an RF value is something you can get from a chromatography lab. Kind of scoot it up or back. It's kind of having a glare here. There we go. So an RF value is something you can get from after you're done with chromatography lab, and it's something that's very specific per drug we're talking about. So this is an example of one that I did earlier. It's just on a little piece of paper. There was 1 dot, 2 dot, 3 dot, and all those dots in the beginning were black, like this one, just little black dots. And when they were dipped inside water, I guess I'll have Max show you now, just cause. So Max, can you put them in the water? So you put them with just a teeny tiny bit of water at the bottom. And because water has its attraction to itself, it's polar, like polar molecules are attracted to itself, it starts pulling up basically it's pulling up water. That's what it's doing. The water's attracted itself and climbing. That's how it climbs up in trees, capillary forces, cohesion forces. But it holds onto that ink at the bottom and starts separating it. So it starts separating it out. And this is actually another completed one because it started this way. It's yellow. And this one was one I did as well. So all just literally that simple. Now, when it's finished, you can calculate the RF value that is specific to each drug, or in this case to each ink. We're going to calculate this small one here. All you do is you take X divided by Y. Now X is the length that's the solute traveled. So this is how far this one traveled from here. So from here to here. So I take that length, literally I measured it with a ruler, and I put it on top as X. On the bottom as Y is how far the water traveled. So it went from here at the bottom of the cup to here at the top of the cup. We take that length and put it on the bottom. So I have 1.43 divided by 4.12, and I get an RF value for this small ink, this marker right here. Its RF value is 0.35, and that would be specific. That specific number, that RF value, would be specific to that type of pen, and we can use that for other types of toxins and drugs. You can see this one's still going. Now, before I start our actual lab, I wanted to mention that I have this little extra credit assignment, because as you can see, it's pretty easy for you to do this at home, okay? So if you wanted to do this yourself, you can turn in a picture of you doing it. You have to be in the picture, so you can't just steal one from the internet. You have to take a picture with you in the cup like this. And you can post that to me, and you will get 7 points on a quiz or a test if you want to do it. All you need is a cup, any kind of cup. You need a little bit of water at the bottom of the cup. You need some kind of absorbent paper, a paper towel, a coffee filter, construction paper would be good choices of things at home. You can try computer paper and notebook paper, but I don't feel like that would work very well. But hey, give it a try. Maybe it will. And then you put little dots of ink at the bottom. Just like I showed you, those 2 dots, it's more fun to use colors that are the same, but they're like different brands, and see how they actually are not the same when they start separating. Like this one is going way faster, it's way higher, it has red and green and lighter green. This one only has black and green right now. So it's more fun when you use the same color and see how they separate. But if you do this little lab right here, send me the picture and I will give you 7 points on a quiz or a test. So that's a lab you could do at home if you wanted to. Okay, so now we really are ready for our lab. So if you haven't looked at your lab paper yet, I've answered all the questions now, I think, at the top, except for who is our unknown bad guy. So if you haven't looked at the story is a woman has a person write a fraudulent check. That fraudulent check, they're trying to match the pin that was used to write it so they can figure out who's the culprit trying to get into this woman's bank account. So if you look, I have a slightly different setup than the one that you can easily do at home. But here we go. So this is one that's already been done. This is one we're about to do. So you can see the process. Here's another one that we did. So basically there's a hole in the center. You put the ink of all the pens as well as the unknown. So the unknown sample is going to go right here. So I put a 1, I put a 2. Like I literally wrote around it so I'd remember which pen was which and which one was the unknown dot. And then, as you can see, Max has had that little thing in his hand the whole time. It is a little paper wick. So this paper wick is literally just the same paper that's been folded up. And he's folded into a little, like, triangle shape. And he's going to poke it inside the hole. So here we go. Max, you can now poke it down and see, so they can see how the lab is done.
I will poke it.
Thank you. Okay, just a little bit. That's good. So now the water will touch the top of the wick. It will start to climb up the paper wick, and then it will start spreading on these dots. And you can already start to see it getting wet probably.
One's turning green.
I can already see the pink and the green coming out of one of them. I'll turn it towards y'all. So you can already see they're separating. I'm not gonna make y'all watch the whole thing because it does take a couple minutes, and I will post pictures of these labs colors so you can tell which one is the unknown. It's pretty easy to tell once you get a clear picture that I'll send you, but this is how I did it. So this is how I got the pictures. You literally just let the water separate the ink. Okay, so that's it from us this week. Hope y'all are doing well. See you next week for another lab.